the dependency inversion principle, or DIP. Now, the definition of this is that high-level modules should not depend on low-level modules. Instead, both should depend on abstractions. This makes the code more modular, testable, and interchangeable, allowing us to swap dependencies without breaking the system. Okay, so you can see here that we have some code which is problematic and violates this principle. The reason it violates this principle is I have this email notifier and I directly couple it or use it inside of this user service. Now, at first glance, this may not seem like a big problem, especially because the code is small, but the issue here is that we've directly written in this implementation, email notifier, inside of this user service class, which now means our code is completely limited to just being able to use this. And if I wanted to set up some kind of other notification service, maybe using an SMS, maybe using a push notification or something, I can't do that without modifying this code. Instead, rather than relying on this direct implementation of email notifier, I want to rely on something like an abstraction, something that may always include this send method, but could work with any type of notification system. So now let's just look at the user service and notice the user service now relies on an abstraction, which is a notifier class or a notifier interface. Now what this allows me to do is use any type of notifier, something that again inherits from this notifier class, like an email notifier or an SMS notifier or a push notifier, and not have to change anything inside of this class. And then we can create an email notifier, an SMS notifier, a push notifier, any other type of notifiers that we want, and nothing changes inside of our user service class. We just rely on this abstraction, which is a notifier, and as long as what's passed inside of here implements the send method, then this code works completely fine, and we can use it with any type of notification service.